We're going to have a look at understanding type 1 errors and the advantages of an ANOVA over multiple t-tests. So when conducting stats analysis, one of the key concerns is the risk of making a type 1 error, which occurs when you incorrectly reject a null hypothesis that is actually true. So in simpler terms, a type 1 error happens when you conclude that there is a significant difference between groups when in fact there is none. This is often referred to as a false positive. Now, why are type 1 errors a concern? So there's an increased risk with multiple comparisons. So the more stats tests you perform, the greater chance of committing a type 1 error. For example, if you conduct multiple t-tests to compare 3 or more groups, each test increases the overall likelihood of finding a significant result, purely by chance, even if no true difference exists. Now, the impact on research, so type 1 errors can lead to incorrect conclusions and potentially misguide clinical decisions, especially in fields like sports rehab, when accurate assessments are crucial for patient outcomes. Now, why is it better to perform an ANOVA than multiple t-tests? So a single test for multiple groups. An ANOVA, analysis of variance, allows you to compare the means of 3 or more groups in a single test. By using an ANOVA, you can assess whether there are any kind of statistically significant differences between the groups without increasing the risk of a type 1 error, as you would with multiple t-tests. We have a controlled error rate, so an ANOVA controls the overall type 1 error rate by maintaining it at a specific level. So, for example, 5%, regardless of the number of groups being compared. This ensures that the probability of making a false positive error remains low, even when comparing multiple groups. How efficient it is. So an ANOVA is actually more efficient and provides a more comprehensive analysis by considering all groups simultaneously. This makes it a more robust tool for studies involving multiple comparisons, such as evaluating different rehabilitation programs or injury prevention strategies. So in conclusion, using multiple t-tests to compare several groups increases the risk of committing a type 1 error, potentially leading to false conclusions. An ANOVA is a superior method in such cases because it allows you to compare 3 or more groups in a single test, controlling the overall error rate and providing a more reliable analysis. For sports rehabilitation and injury prevention studies, ANOVA is the preferred stats tool when dealing with multiple group comparisons, ensuring accurate and trustworthy results.